Hello, my name is Lisa Jablonski, and I'm going to show you how the X-ray circuit and the X-ray tube work. And I'll take you through the whole process step by step. And to help us, I'll be using these diagrams. Here we have the X-ray circuit, and here we have the X-ray tube. And using those should help make it more clear. So first, we'll start with the X-ray circuit. And to begin with, you need electricity to start with, and it comes from outside the house. And you turn on the main switch or the main breaker right here. And from outside the house, you'll get 220 volts or 60 hertz of alternating current or AC. And nearly all X-ray equipment operates at those levels. Then there's a transformer outside the house or the building that converts that 220 volts to 110 volts before it goes inside the house or the building. The 110 volts enter the X-ray circuit. Once in the circuit, the electricity will flow in 3 lines. And I have them diagrammed here. Number 1, right, starts here. Number 2 is here. And number 3 is here. So there are 3 different lines. Now, those 3 lines, line 1 and 2, they complete the cycle of the auto transformer. I'll show that later. Line 3 is not connected to the auto transformer. And the electricity flows in these 3 lines all at the same time, simultaneously. So now the exposure switch, let's see, which is right here. The exposure switch, it's a connection that permits the electric current to flow through the X-ray circuit, and it also activates the rotating anode of the X-ray tube. And I'll talk about the anode, the rotating anode a little bit later on. The technique settings we will use in this case, we'll set it at 120 kilovolts or kVp, and 25 milliamperes or MA. Now, kilovolts are the quality or the strength of the X-ray photons, and the milliamperage is the quantity or how many X-ray photons there are. You set the kVp with the auto transformer, and it's right here, the auto transformer. It sets the kVp. And you set the MA with the variable resistor, which is right down here. That's how you set the milliamperage, the MA. Let's see. The kilovolt meter will read the setting 120 kVp at 25 MAs. So that here is the kilovolt meter right here. It reads it. Okay. The auto transformer sets the kVp, but the kilovolt meter reads the kVp. And then the filament ammeter, it only reads the MA, and here's the filament ammeter here. It only reads the MA, and it will read it through induction. Now, induction is a process of electrical fields acting on one another without contact. Through induction, electricity can cross over even though there's no contact. If there was a connection, the X-ray circuit would get confused and it wouldn't work. There are 6 locations where induction happens in the X-ray circuit and the X-ray tube. So I'm going to show you right now. So here is first, number 1, the place of induction, number 1. Second place right here, number 2. The third place, number 3. The fourth place right here. The 5th place here, and then the 6th place is in the X-ray tube itself, right here. So those are the 6 places where induction happens. Now the timer sets the time of the exposure, and okay, here is the timer is right here. So if you set the time for 3 seconds, then you have to hold the timer button down for 3 seconds until the audible and visible indicators have stopped. So usually there's a buzzer that you hear and a light that you see to tell you that the exposure is finished. Now in the X-ray circuit, there are 3 sections. I'm talking, the overall whole X-ray circuit. There are 3 sections. So the first section, there you have the low voltage or primary circuit is this area. Then you have the high voltage or a secondary circuit is this area. And then you have the filament circuit, which is the area down here. So those are the 3 main sections of the X-ray circuit. So going from the low voltage side to the high voltage side, if you look here, these are coils here on the low side and here on the high voltage side. You can see that there are more coils on the high voltage side. And that means that it raises the voltage as you go from the low voltage side to the high voltage side. So it's called the step-up transformer. If you go the other way, the low voltage side, the high voltage side to the low voltage side, of course, there are less coils going that way, so the voltage goes down, and that is called the step-down transformer. Okay, so here we have the high voltage step-up transformer, okay, and then down here we have the filament step-down transformer. From 110 volts, the electricity passes through the step-up transformer, okay, here, and right here, the step-up transformer, and it is raised to 10,000 volts. Now, on the other hand, when the electricity crosses the step-down transformer, okay, down here, it goes from 110 volts down to only 5 to 15 volts and only 3 to 5 amperes. Now, the job of the MA meter, which is right here, you have the MA meter, it measures the MAs, and then the other job of the MA meter is to measure the 10,000 volts as it crosses the step-up transformer. If there are more than 10,000 volts, like maybe 15,000 volts, then it will just stay on the the MA meter will store it in the ground. Okay, so here is the ground. If there's more than 10,000 volts, then the MA meter is going to store it right there in the ground. Now, if there are less than 10,000 volts, then it will just stay in the low voltage side and no exposure will happen because there's not enough voltage. If you do have your 10,000 volts, then it will be stored in the capacitor. And then it is sent to the falling load generator, where the 10,000 volts, it'll be released one drop at a time, kind of like a faucet, because if it's not released a drop at a time, the falling load generator will get overloaded. So it needs to go a drop at a time in the falling load generator. Then, drop by drop, in the falling load generator, the 10,000 volts travels to the rectifier, and it'll be changed from alternating current, or AC, to pulsating direct current, or DC. And I'll show you, the rectifier is right here, this square area. So the rectifier changes it again from alternating current, AC, to pulsating direct current, pulsating DC. Now, there are 2 pathways of the rectifier that I can show you on my diagram. And I have them highlighted, so it makes it real easy. The first pathway is the yellow. So it's going to go here, travel here, and then around, here, and there. So that's the first pathway. The second pathway I have in pink. You can travel this way, and it goes up, around, and that way. Okay, so those are the 2 pathways in the rectifier. Let's see. And those, by the way, those pathways are happening simultaneously also. They happen at the same time. And also, each path, there's a point where it's the one path, it's parallel to itself. Like if we look at the yellow part, right here and here, it's parallel to itself. And then the pink, here and here, it runs parallel to itself. Now, after the rectifier, the electricity can finally get to the X-ray tube, and it travels into the X-ray tube. So first, I'll tell you a little bit about the whole tube. The tube is made of glass, so all this is glass, and there's a vacuum inside of the glass. So there must be a vacuum because the removal of the air permits the electrons to flow from the cathode to the anode without encountering gas atoms of air, and it greatly increases the efficiency of the X-ray tube's operation. So you have to have a vacuum inside of the glass tube. Now, the cathode end of the tube is over here. The cathode, and it's negative. Okay, that's why there's a minus there. The cathode has a negative charge. It's negatively charged, and the anode is positively charged. So here's the anode end, positive charge. Cathode end is negatively charged. The cathode assembly, it contains the filament or filaments, the focusing cup, and associated wiring. Okay, so we need the filament here, and then the focusing cup is right here, and whatever wiring that you need. That's part of the cathode assembly. Okay, let's see. The filament, it's made of tungsten because of its high melting point, and it's difficult to vaporize. And also, rhenium and molybdenum are also used because of the same properties. So the tungsten is going to be used here, and also molybdenum and rhenium, they are used. The cathode produces a thermionic cloud, which means a cloud of electrons. And it conducts the high voltage to the gap between the cathode and the anode. And it focuses the electron stream as it heads toward the anode. The anode assembly, over here, it contains the anode, the rotor, and the stator. So here is, the stator is right here. They're electromagnets, the stator, and the rotor is here. Okay, so that is the parts of the anode. The anode has a target. Okay, right here is the target. And the high-speed electrons, they're suddenly stopped on the target, and that results in the production of X-ray photons. The electricity comes in from both sides of the X-ray tube. So you've got electricity coming in from here and electricity coming in from here. Okay, on the anode side, the electricity, it turns the rotor. Okay, the rotor is over here, and it actually spins around, turns around. And it also has ball bearings. You can see the ball bearings here. That helps it, the ball bearings right here on the rotor. That helps it to turn easily and spin easily. The high-speed anode, it's really very desirable because the high speed, it helps to dissipate the heat because the X-ray tube is going to produce a lot of heat. Now, the stator is the only part of the anode that is outside of the glass X-ray tube, okay? Because you can see here is the stator here and here. It's outside of the glass tube. It has powerful electromagnets. Okay, these are electromagnets, okay, here and here. And again, that's a place of induction because they still go back and forth, even though they're not connected, they're not touching, they can interact with each other. And that happens to be, like I showed earlier, the sixth place of induction. The anode also has the target made of a tungsten. And again, tungsten is used because of its high atomic number, high melting point, and heat conducting ability. On the cathode end of the X-ray tube, The electricity comes in from the filament circuit. So over here, it would be the filament circuit comes in on this side, okay? And the electrons reach the focusing cup. The focusing cup is going to compress the thermionic cloud, make it smaller, because here is the focusing cup is right here, and there are electrons all lining the whole surface of the cup, and all those electrons, they won't allow all the other electrons to leave a straight line. They have to travel in a straight line because the like charges repel. So the focusing cup right here, it's not allowing, electrons can't go up here, they can't fly down here, they can't go up here, because the cup is repelling them and making them travel in a straight line right here. Okay, then the electrons from the cloud, the thermionic cloud, finally reach the target of the anode. Okay, right here is the target of the anode. Okay, the high-speed electrons, they're suddenly stopped, and it results in production of the X-ray photons. And that, kind of in a nutshell, quickly, that's how electricity becomes X-ray photons. Okay, all that process, that's how electricity becomes X-ray photons. So thank you for listening, and I hope you learned something, and I hope there aren't too many questions and I made it clear to you. And thanks again for listening, and hope you enjoyed it. Thank you.